If you need to switch something on your boat, this setup will help you with the KIP dashboard and the Shelly 12 volt. Let's take a look. During summer I did 3 major improvements. We discussed already one of them the last time, and today it's part number 2, so the second one. Last time we discussed already the smart shunt to measure the battery capacity, current and so on. We will discuss the anchor alarm, that's a longer video, let's say, and this time we talk about the Shelly 12 volt switch, which I use to trigger my charging, and that's what we're gonna do today. Guys, I had some footage of my engine, the alternator and so on, but let's say it's gone, so we need to improvise a bit. And I did a simulation on my development environment here, a simulation of the Shelly device, which is switching the charging of my battery, of my lithium battery, only of my main battery, not of the starter battery, on and off, and this will be triggered by the temperature of the engine. So you may ask, why did you do that? And the answer is quite simple. My battery, my lithium battery and my main battery are charged by the alternator. And the lithium battery takes up to 30 amps while charging. And when the engine is cold, you really notice how much force must be generated by the alternator. And yeah, it may disturb a little bit the usual purpose, and the usual purpose is going forward or backwards with the propeller. So what I wanted was I wanted to only charge the battery when the engine is warm enough, and not when I directly started the engine and already have this high load of my lithium battery. So that's the purpose, and for that we don't need much actually. We just need the Shelly device and a temperature sensor on the engine itself. So you need a temperature sensor, not part of our video today because I did this in several other videos. It's a one-wire sensor which will send the data to signal K. And because I lost my footage, I have a picture here of my engine. You see where I mounted the one-wire sensor at the exhaust part, let's say, and that works very, very well, by the way. And what you see on this picture as well is a compression measurement. I made an adapter of the injector, but that's a different story. And the right choice is the Shelly 1 device. The Shelly 1 has 2 things we need. It can run with 12 volt supply, so which we have on our boat. And additionally, this input here is not switching the supply itself, so 12 volt. It's switching whatever you have on the input, it is switching to the output. And I wanted to switch D plus of my alternator. So the information if charging is on, let's say, if the alternator is on and the engine is on, because yeah, I want to switch based on temperature, but even if the temperature is high enough, I only want to turn this on, of course, if also the alternator is running. So here in my simulation, you see how it should work. On my simulation, I will now switch the temperature always from below 40 degrees, which is my threshold, to above 40 degrees. And you will see that charging will go on and off, which depends now on the engine temperature. When the charging is on, it just means that the D plus is given to my charger. So if D plus is off and charging is on, it will still not charge, of course, because D plus is off. So this just means if charging can be activated because of the engine temperature. And this is through an automatic mode. I can also switch off automatic mode, of course. And when I switch off automatic mode, then charging will be set independently of the engine temperature. Even if it's going down, I can now decide if I want to charge or not. So we are now in Node Red. This is the embedded installation in Signal K. So we have the Signal K nodes automatically installed. And we start to grab the temperature sensor. I will give you and guide you through the basic things, but not all details. You can just take my code afterwards. So let's start. We subscribe on the path of the engine temperature sensor. You need to know this path. You can look it up in Signal K if you don't know it. And yeah, we simply subscribe, put a debug node on, and go. Now we get temperature values in Kelvin, by the way, here on our debug node. I had to add a source, and this is only necessary if this is a special source, let's say. So in my case, I write the data from a simulation out of Node-RED into the sensor because I don't have a sensor connected today. On my boat, I don't need to specify the source if you have just one source. Even if you have several sources, multiple sources, it's not necessary usually. However, then you might get several values. So it is a good idea to specify the source if you're sure which source it is, but usually it's not necessary if the source is a sensor. We need the put handler. A put handler is necessary if you have a switch, like the toggle switch, and you just simply put the path of the switch you also have in the KIP dashboard. I did show this already to you. So here in the KIP dashboard, the same path which I have here for the switches must be also in our Node-RED toggle put handler. So I did configure both put handlers here with the paths I mentioned. And let's check this now. When I change the switch, you see I got a false here. When I put this one also false, and when I switch it back, I get a true. And if I switch to this one back, I also get a true on the different paths here. So the switches are working. And one important hint, it is unfortunately that way that these switches will not remember their position if you don't write this one back to the path. So even if you think, yeah, the path is now true, this is only the put handler. You need now, if you want to store this permanently, if you want to persist it, you need to write now the position of the switch back to this path. The easiest way to do this is, now let's remove the debug node here from the temperature sensor. The easiest way is you put a send value in, so send path value, and you have to add path and usually which is the topic if you do not specify it, and the payload is what the payload is. So we can just simply connect these two, and let's change our debug node to the complete object, and let's start. And when we now take a look at, I just changed the switch, you see that the payload is true and here's the topic. So when we send this, now we really get this information on our path sent back, and we can check this here on our switch. So for example, if I use the automatic switch, you see it's true. When I switch it off, it should go to false, and when I switch it on again, it should go to true. And again, if I don't connect it here, even though I have the switch connected, let's check this again. So here's true. We do it like this, switch it, and you see nothing happens. It stays on true. Was the wrong switch anyway, but it stays on true when I put the automatic switch. So you need to send it back. That's important. And now you can do anything with that, but this should be established as well. So second step, you see I added a function node, and this function node is now calculating if a switch shall take place. First of all, we take the engine temperature and we calculate it in degrees Celsius because I want to specify a variable here, hot enough, and this is now 40 degrees Celsius. So that means when it's above 40, I want to switch charging on. If it's below 40, I want to switch charging off. You see, I have also a flow variable here, and I check if it's existing. If not, I set it to true. So I want to know if the Shelly is currently on, and if automatic mode is on, that's the other switch I have. And then I have two variables I want to return. And now there is a check if the engine temperature is above hot enough. and if the Shelly state is false. So only if the temperature is hot enough and Shelly is not already on, it will send out 1 to the message object. And if the engine temperature is below hot enough and Shelly is on, it will send message output 2 to the message output. So the idea is output 2 is triggered if it shall switch to off, and output 1 is triggered if it shall switch to on. The missing piece is the Shelly. When you have a Shelly original firmware, you can use the Shelly nodes of Node-RED. You have, of course, to install them from the palette. And when you have installed them, you can configure them. Device type is then our Shelly 1. On my boat, I have a Shelly Gen 4. Here at home, a Shelly Gen 3. But let's take the Shelly Gen 4 here, not Mini here. Oh no, this is the PM Shelly 1. Where is it? Shelly 1 Gen 4 here. And by the way, you can use mode none if you don't need the information if Shelly is switched on a different way. And as I only switched the Shelly with my Node-RED here, I decided to go for none because this keeps traffic low. Otherwise, you want to know if you maybe with the app or something change the Shelly status, or with the switch when you use the switch. As I don't do that, you can keep this to none. Of course, host name, which is your IP address of the Shelly, must be entered. And then when you did this, we can send information to the Shelly, so we can translate now our temperature check to the Shelly. And I will copy now from my solution the on switch to explain this here to our Shelly. And this is now doing the following. If this is triggered, it will set, by the way, the flow variable, but the main thing is it will create a JSON object with a method, and this is switch set, and parameters ID 0. This is if you have a Shelly with just one output, always 0, and on to true. And now I can connect this one here to my first output here. And then I have the same for off. And what it's done here is, as you might expect already, exactly the same, but the on option is set to false. And so we can trigger, based on our calculation, the Shelly device. And you can see here, let's go back to my Shelly on my boat. So you can see here the IP I have on my boat. So that's what you need to find out. What kind of IP do you have on your Shelly, and you set it. Look at the final code. You see some little changes. So I have an init here to get everything, even if I get no temperature sensor, to a default state. And I moved a little bit around the on and off for the buttons, but it's more or less the same what I showed to you. You see also that I've write back here the status of my switch. Okay, what you might notice, where is my Shelly switch? So this one here. And this is only now for my demo because I have a Shelly Gen 3 here, which I flashed with TUS motor, so I can't use the node for the original firmware. So I had a HTTP request node. I will provide the code with the original firmware, so this is only now for my demo. And you see here already my charging is going on and off, always when my engine temperature simulation goes on and off, or not on and off, but high and low. And when we take our debug node here, we can see this directly. So let's use the debug node, and here we can maybe use this here, these two outputs, and you will see power on. This is now a bit different than on the Shelly original, but this is what I get on the HTTP request, and power off. So it's always switching on and off based on the temperature. But when I turn automatic off, also this is now written back to signal case so that it's really persistent status. So now it's off, and in my calculation on the temperature check, it says only if automatic is on, please go through this routine. Now only this button here, the charging button, has an influence. If I turn charging off, of course, I have a LED connected here. It will go off, so I can see that the Shelly is really switching. And you see this also here on our routine. And here it's going on again, only with the button. So to demonstrate this, you see here the blue LED, and you hear maybe the click of the Shelly. So that's the relay of the Shelly, and this is exactly how I did it on the boat as well. Hope this helped, and next time we do the anchor alarm. This will be a very interesting video, I think. And if you need the source code, you find it on GitHub. So have a good day. Bye bye.
See you next time.